So now let's look at the one exercise. So first, let's begin with such simple facts. And let's see, we have the sine of pi over 6 equal to 1/2, right? And we have the cosecant of the pi over 6 equal to 2. So pi over 6 is in the range of the inverse sine and also in the range of the inverse cosecant, right, in this interval. So now you can see inverse cosecant of 2, this is equal to pi over 6. And also inverse sine of 1/2 is also equal to this pi over 6. Right? So you have the inverse sine of 1/2 is equal to pi over 6. So that means we have such relationship between the inverse of the sine and the cosecant. You have the cosecant inverse of 2 equal to inverse sine of 1/2. So actually, for any x for which the absolute value of x is greater than or equal to 1, so that this x is in the domain of the cosecant and secant, we have this identity that is the inverse cosecant of x is equal to inverse sine of 1 over x. Okay, see here the x is equal to 2. We have the inverse of cosecant of 2 equal to inverse sine of the 1 over 2. Right? And similarly, we have the inverse secant of x equal to inverse cosine of 1 over x. Okay, and this holds for the x such that the absolute value of x is greater than or equal to 1. Now let's look at another fact. We have the inverse cotangent of root of 3 equal to pi over 6, because the cotangent of the pi over 6 is equal to root of 3, right? And also pi over 6, this belongs to the domain, or say the range of the inverse cotangent, that is the from the 0 to pi, right? So this belongs to the domain of the arranged function or the range of the inverse function. So then we know the inverse cotangent of root of 3 is equal to pi over 6. And let's look at the inverse tangent of the 1 over root of 3. This is same as the inverse tangent of the root of 3 over 3, right? You just rationalize this fraction, then you get the root of 3 over 3. And we know this is also equal to pi over 6, because you have the tangent of the pi over 6 equal to root of 3 over 3, and pi over 6 also belongs to the range of the inverse tangent, right? So now from here we know inverse cotangent of root of 3 equal to pi over 6 and equal to inverse tangent of the 1 over root of 3. Okay, so this is the first fact about the inverse cotangent and tangent. And here, the root of 3 is bigger than 0, right? So we'll deal with the case when the input is positive. Now let's look at the case when the input is negative. Let's see what is the relationship between the inverse tangent and inverse cotangent. So another example, we have the inverse cotangent of -1. Tell me what is the angle for this? Pi over 4 or negative pi over 4 or anything else? What is the angle? How much? Pi over 4? Cotangent of pi over 4 is equal to 1, not equal to -1. Right? What is the angle? Say again? 3 pi over 4. That is correct. Because 3 pi over 4, this belongs to the range of the inverse cotangent, which is the open interval from 0 to pi, right? And also, cotangent of the 3 pi over 4, okay, and this is equal to the cotangent of the pi over 4 up to a side, right? And we know this pi over 4 is the reference angle of the 3 pi over 4. And the cotangent is negative in the quotient 2. So we just prefix a negative sign before this cotangent of pi over 4 to get the value. So this is equal to -1. So that means this inverse cotangent of -1 is equal to 3 pi over 4. Now let's look at the tangent, inverse tangent of -1, or say the 1 over the -1. So the same as the inverse tangent of -1. Now tell me, what is the inverse tangent of the -1? What is this angle? For which angle the tangent is equal to -1? We know tangent of pi over 4 is equal to 1, right? Then what is the inverse tangent of -1? Yeah, what is the inverse tangent of -1? Negative pi over 4. That's correct. And this really belongs to the range of the inverse tangent, which is the negative half pi to half pi. Right? Okay. Now, let's see the relationship between the inverse cotangent of -1 and the inverse tangent of 1 over the -1. So, this just implies you have the inverse cotangent of -1, which is equal to 3 pi over 4, right? And this is same as the pi plus negative pi over 4, and this is equal to pi plus the inverse tangent of the 1 over the -1. Okay, in what? You have the inverse cotangent of -1 equal to pi plus inverse tangent of the 1 over -1. Actually, right now I have seen two examples in which we have the x bigger than 0 and x less than 0. Here this negative 1 is less than 0, right?